Hi there! In this series I'll show you how to store your GPG private keys in a Yubikey. There's 3 main reasons why you would want to do this. First, your secret keys will never leave the Yubikey, so all the cryptographic operations that we perform will happen on the Yubikey itself, and not in your OS memory. Second, once in a Yubikey, your private keys are non-exportable, so unlike with a PC, no one with physical access to your device can steal your keys. And third, you don't have to remember strong passphrases nor deal with multiple files or data directories to use your keys on any computer that you like. Yubikeys will brick themselves by default after just 3 failed password attempts. In other words, a Yubikey is basically a hardware wallet for PGP keys. So, today I'm going to show you how to create a PGP master key. This key is supposed to be used for certification purposes only and should never touch the internet. Once created, it will issue subkeys for signing, encryption and authentication. These are the keys that will eventually burn into a Yubikey. You'll need the following items to complete this guide. First, 3 or 4 brand new USB drives that have never been used before. Second, a computer with an internet connection to download some software and create a bootable USB drive. And third, a computer with no Wi-Fi card, no Bluetooth card and no hard drive. A computer that will never, ever, be connected to the internet again. A cheap old laptop will do nicely. Such a machine is an invaluable tool for dealing with private keys offline. But beware! Dealing with air-gapped devices requires constant vigilance and a paranoid stance at literally every step. So today we're not dealing with Yubikeys yet, but when we do, everything will depend on how thoroughly you followed today's instructions. We're generating the master private key, the most important key of all. And if you want to sleep well at night after you encrypt some of your secrets into a file or access a remote personal server through SSH, you need to know that you did everything right. So take this first video very seriously. I'll be doing everything myself and guiding you throughout the whole process. You just have to follow along. I won't skip any step, but I won't stop. One more thing. I'll be using Linux. Of course. Let's go. First, we will download the Linux Tails operating system. Follow these links to get the image file, its digital signature and the signing key. I will verify the digital signature of the image file by importing the signing key, and then verifying the signature file. If I get a good signature I will delete both files, and move the Tails image file to my home. We now have a Linux Tails image. You should do some basic research about what Tails is, and what Tails does. Basically it is a security and privacy focused Linux distribution. It's designed to be booted from a USB drive and to reside temporarily in the host machine's memory. To create a bootable Tails USB drive we'll use Balena Etcher. You can go ahead and download the software by clicking the button below. Or alternatively, you can go to their GitHub, and add their package repository to your sources. That way you will stay up to date by just updating your system. Now I will run Balena. There's just 2 steps. First, select the Tails image we downloaded a while ago. Second, insert a brand new USB drive into your computer and select it as the target. Congratulations! You have completed the first part of this guide. Now we move on to generate our PGP keys. This will happen on an air-gapped computer, running Linux Tails booted from a USB drive. To do this, you might have to tweak your BIOS boot settings. Do your own research. You might not have an air-gapped machine yet. And that's okay. You don't have to commit right away to create a definitive set of PGP keys, and you can play and practice all you want running a regular OS on a regular computer. But remember, when generating your long-term personal keys, you will want to do this right. We are offline, in a computer with no Wi-Fi, no Bluetooth, and no hard drive. This machine will never go online again. Linux Tails will live in our PC's memory for as long as we keep this session going. On shutdown, everything will be forgotten. Let me start by opening a terminal window, and making it pretty. I will also delete those items from the desktop, as well as the default GPG data directory, which is situated at home. Now I will create a directory in the desktop called My Keys, where I will store important files regarding my PGP keys. The first of these files is the password for the master key, which I have to generate. I will make it a long strong passphrase. Note that I would never dream of doing this in a setting different than that which I've discussed. Air-gapped computer, minimal hardware, perpetually offline, Linux Tails. Remember to copy the password into your clipboard. Now, the following command will allow me to create a PGP master key, with certifying capabilities only. Notice that I will go for an RSA key, and that I will get rid of signing and encrypting capabilities, so I will be left with certify as my only allowed action. Next, go for maximum key size, and make sure that this key never expires, since it is your master certifying key. Regarding its identification, whether or not to add a real name and email, I would recommend that you learn about the PGP Web of Trust before going further, and then decide. It is a subtle issue, which will be clarified somewhat when you learn about subkeys. For the purpose of this tutorial, I will name my master key after my mentor, the Penguin. Adding an email, real or fake, will be useful to ID your key, so I would recommend you do so. Paste your password. Great! I have a master certifying key. That long string of hexadecimal characters is its fingerprint. It has one identity associated with it, or UID. When referring to a key, we can use either its fingerprint, the email attached to any of its UIDs, the last 8 hexadecimal characters of its fingerprint, also known as short ID, or the last 16 hexadecimal characters of its fingerprint, also known as long ID. This is the key that we will always keep safely away from any computer connected to the internet. Every time we interact with our master key, it should be in this way, offline, with a permanently air-gapped computer. In Linux Tales. Now, we will use our master key to derive 3 keys that we can later use to burn into a Yubikey, and do cool stuff with. These are called subkeys. I will go through the same process 3 times. Editing our master key, for issuing a key for signing, a key for encryption, and a key for authentication. These keys will have a shelf date of, say, 3 years. This is considered good practice because it minimizes the risk of keys getting compromised at some point in the future, and forces you to reissue new ones periodically. The keys would still work, but would be flagged as expired. In our case, they are going to be pretty safe, always inside a Yubikey, but we will stick to best practices. Back to the terminal. Remember that the master key password is still in our clipboard. And note how I use the email to identify the master key in the following command to generate a signing subkey. Notice how the list of our keys has updated. We now hold 2 keys. The first one is a master key with its usage marked as C, or certify. The second one, a subkey with usage S, or sign. I will now generate a subkey with encryption capabilities. We own a new subkey, with usage E for encryption. Let's issue one last subkey with authenticating capabilities. Later in the series we will use this key for SSH authentication. You'll notice that when I try to add an authenticating subkey, there is no option for it. We will have to do the toggle trick that we did when we created the master key, by selecting an option that allows us to set our own capabilities. Just get rid of sign and encrypt, and make the subkey A only. We are finished. To save and exit, type save. Please make sure that you understand all the information above. Type of keys, fingerprints, dates, usages, UIDs, and trust, which for our keys is ultimate. Do some research about it. Our GPG keyring holds all the keys that we set out to generate. Now we are going to export everything that we have done, and more, into a few convenient files. I will save all these files next to my password, in the directory that I created at the beginning of this guide. My keys. First, I will export the master private key, for which I will have to provide the password. Next, I will create a revocation certificate for the master key. Imagine that you lose control of your keys, or they get compromised in any way. If you have a revocation certificate, you can at least advertise the fact that those keys should not be trusted, and create a new PGP identity. But beware! Anyone in possession of a revocation certificate for your keys can render them useless. It is a double-edged sword. Now we get our public key. No need for passwords, obviously. Next, we export the secret key for the subkeys. Password is needed. And finally, it is useful to know the fingerprints of all your keys. With the following command you can print them all to screen. So let's put them into a file. We are done exporting files. Let's put them into the GPG data directory, situated at home. Let's take a final look at what we've got, before backing everything up. A master certifying key, and 3 subkeys. For signing, encryption, and authentication, good for 3 years. Everything is correct. So I will save the GPG data directory into a tar file, and leave it on the desktop. Finally, you will want to copy this backup into multiple reliable storage devices such as industrial-grade micro SDs and high-quality USB drives. I will do this once, but you should have multiple backups. I will use loops to encrypt a partition in a brand new USB drive. And I will use a strong passphrase. This passphrase I will not memorize. Rather, I will write it down in a piece of paper, and store it safely, away from the backups themselves. If you created an encrypted partition, try it before shutting down Tails. I will do this myself. Eject the USB drive, and mount it right back in. I will also provide a wrong password to unlock the volume, before trying the correct one. All good. I can now shut down Tails. Well, you did it. Now you have in your possession, securely generated, personal, unbreakable PGP keys. There's few things that I can think of that are sexier than that. Next time, we will make a Yubikey work in Linux, learn how to set it up, and flash our subkeys into it. See you then.